Assalamualaikum everyone. My name is Normashita Betu Sulaiman and my student ID is 2018801472 and today I'm going to present my FYP. My FYP title is a review on various types of seaweed as renewable resources for bioplastic production. So this is my table of contents. In my presentation, I'm going to present Chapter 1, Chapter 2 and Chapter 3. Okay, let's proceed to background of study. Plastic play a critical function in our daily life, donating to our health, safety, and mental well-being. Plastic materials, whether synthetic or semi-synthetic, mostly polymers of huge molecular mass generated from petroleum and natural gas, are today considered very significant material due to their improved performance over metal and wood. Plastic's spectacular surge in using in owing to its inexpensive cost and superior qualities such as flexibility, rigidity, delicacy, potentiality to be molded into a variety of forms, and lower weight, but plastic is non-recyclable and will remain in the environment for hundreds of years. Next, let's proceed to problem statement. According to present trends, the world will run out of petroleum sources in a few years, which cannot be renewed. As a result, the globe will exhaust its resources from producing plastic, particularly for industrial packaging, which play a significant role in our daily life. Non-biodegradable plastic are particularly visible in the trash stream owing to their size, and they take a long time to disintegrate and can lead to environmental pollution. By doing this research, it is hoped that the biodegradable plastic from seaweed can be produced and can contribute to environment control. Okay, next significance of study. As renewable resource for bioplastic manufacturing, seaweed provides several advantages. The use of several types of seaweed as renewable resources for bioplastic manufacturing may be less damaging to the environment than the present toxic chemicals. Seaweed is good for biofuel production methods such as anaerobic digestion for biogas generation and fermentation for ethanol generation. The main objective of this review article is to discuss the properties on the various types of seaweed as renewable resources used for bioplastic production and to review the mechanical properties of biodegradable polymer or polymer blend from seaweed. Bioplastic. Bioplastic are generated from sustainable resources such as corn sugar, potato, and other plants and are created by a variety of microorganisms. Plant microbes and algae are used to make bioplastic, which are polymer manufactured from renewable biological sources. Bioplastic have several benefits over traditional plastic, including reduced release of fossil fuel, non-toxicity, ease of recycling, lower energy requirement, renewable, and environmentally favorable. However, they were not widely used since they were pricey and also because they were derived from biological sources. Bioplastic statistical data. The worldwide measurement for bioplastic is predicted to be 327k tons with a world consumption of about 12.3 million tons. This implies that there is a high need for bioplastic as its output, resulting in a failure to satisfy the standard for their use and that the technology is still in its infancy. The bioplastic business is expected to be worth $20 billion by 2020. Okay, next for bioplastic sources. There are three types of sources which are plant, bacterial, and algae. For plant sources, starch-based sources such as wheat, cornstarch, rice, sweet potatoes, barley, and cellulose derivative account for around 80% of the bioplastic business. One of the most common bioplastic is thermoplastic starch. Genetic engineering is being utilized in the plant to generate next generation bioplastic, which are made directly in the plant. Two examples are genetically modified is corn and potatoes. Aside from the positive, bioplastic generated from plants have certain drawbacks such as restricted biomass and influence on the human food chain and no longer production time. For bacterial sources, they are the organisms that have received the greatest attention in terms of bioplastic synthesis. As energy and carbon reserve in their cell, many bacterial species develop internal polyhydroalkanoids (PHA) granules, factors such as the requirement for precise conditions for bacterial culture, contamination, specialized equipment and infrastructures all hinder the manufacturing of bioplastic from bacteria. For algae sources, algae are autotrophic organisms that range in size from unicellular to multicellular. Microalgae such as seaweed have greater potential than the previously mentioned sources due to their high biomass, ability to grow in the variety of circumstances, low cost, simplicity of cultivation in natural situation, and ability to be harvested all years. Seaweed are well known for the natural polysaccharides that can be derived from them, which are widely utilized in the sectors of food technology, biotechnology, microbiology, and even medicine, but not yet in the plastic business. Because they are renewable biomass resources and polymer generated from sugar containing carbon, they might be used to produce biodegradable and high-quality bioplastic. Seaweed are commonly referred as bigger microalgae. Three main groups are known as microalgae, such as brown algae, which is Phaeophyceae, green algae, Chlorophyta, and red algae, Rhodophyta. The prospect of converting algae to plastic is great, since algae often include a high protein composition, which accounts for 50 to 70% of its overall content. Algae have been identified as a novel source that is already being worn in the general of sector and application. Previous studies have focused on its potential to be a major source of biofuel in order to identify other alternative fuel to replace petroleum. The composition of algae revealed that they include a substantial quantity of protein polymer, which can be modified to a flexible structure by some chemical treatment for protein denaturation. Polysaccharides are a component of seaweed that are used to make bioplastic. Carrageenan, algal floridia starch, and alginate are examples of seaweed polysaccharide. The dissolved polysaccharides mixture is first centrifuged to remove the dense cellulose particle, then filtrate to remove the smaller particle, and finally evaporated to remove the water. The polysaccharides are then retrieved using one of two ways. In the first approach, to enhance the gelling temperature of a concentrated polysaccharide solution, a potassium chloride solution is added. First filtrate gel quickly. After that, the gel has been frozen and compacted, the eliminate surplus water. The concentrated solution can also be precipitated in isopropyl alcohol because polysaccharides are insoluble in alcohol. The filtrate is a coagulum of polysaccharides, water, and alcohol. To eliminate extraneous liquid, the coagulum is crushed and vacuum dried to remove any trace of alcohol. A belt dry is used to dry the substance, and the complete product is blended to exit specification. Biodegradability of seaweed. Seaweed is one of the polysaccharide-based polymers that may be completely destroyed in the natural environment because the natural degradation process often includes soil microbes whose activity necessitates nitrogen consumption. The biodegradability of material devoid of nutrients such as cellulose and starch is thought to be lower than seaweed. Seaweed matrix blends with cellulose reinforcement. Cellulose and seaweed are excellent starting material for a variety of applications. Seaweed film offer a lot of promise for usage in a variety of applications. They usually don't have enough mechanical qualities such high toughness because of its expansional mechanical properties. Cellulose is a great reinforcing material for improving composite performance, as previously described. Previous research has also found that incorporating a hydrocolloid into a polysaccharide film can enhance the film mix. The combination of cellulose and seaweed increase the characteristic and increase the performance of the composite in the different types of application, including food wrapper, and biomedical application. Kappa carrageenan includes one sulfide group inside the molecule, which is positioned on the O3 galactose ring and produce a highly solid but brittle gel with the presence of the potassium, which is K plus ion, producing the stronger gel. Two kinds of K carrageenate are used, which is refined and semi-refined carrageenate. Refined carrageenate has only 1 to 3% insoluble matter, but semi-refined carrageenate can contain up to 50% insoluble matter. As a result, semi-refined carrageenate is significantly less expensive and is widely utilized in the production of meat products, either alone or in combination with refined carrageenate. Kappa ficus alvarezii is a red algae species. Black seaweed may be our environmental savior when it comes to replacing hazardous plastic, since it has high oxygen and moisture permeability, which are two key properties for fresh product packaging to increase shelf life. Green seaweed, Caulopa lanterifera, is known for its richness of cellulose. The cellulose extracted from seaweed through alkali treatment and acid hydrolysis was confirmed by FTIR characterization. The bioplastic were prepared from seaweed-based cellulose by using casting method and were revealed to have tensile strength. The water absorption permeability decreased in addition to cellulose due to hence water resistant. Sargassum polycythum is a seaweed that contains chemical compound and can be used as antibacterial. Sargassum seaweed is a high nutritional value food that contains carotenoids, cellulose, protein, aspartic, and glutamic acid. Polysaccharides found in sargassum seaweed help to maintain appropriate blood pressure and blood sugar level. In the textile industry, sargassum polycythum acts as thickeners for the paste-containing dyes. In food industry, the gel-forming ability of sargassum polycythum are used for the production of jam and syrup, and also in the medical field. In conclusion, this review demonstrates that seaweed has the ability to create film from polymerate material. The study of seaweed in terms of compatibility and biodegradability has confirmed that seaweed are suitable for creating biodegradable and cost-effective blend film for a broad variety of applications. As a result, it is worthwhile to further research this newly discovered composite material in order to make highly sustainable, useful, and cost-effective good. Even if bioplastic derived from seaweed are similarly costly but have gained prominence in recent years. In this study, the polysaccharide from seaweed is suggested as a renewable resource for bioplastic production. For recommendation, it is suggested that a real experiment using renewable resources for bioplastic manufacturing utilizing various species of seaweed integrating with polysaccharides from seaweed as natural antioxidant be carried out. With actual and experiment correct data on seaweed polysaccharides may be produced, as well as different things that can be analyzed from the experiment. Finally, 2 to 3 different kinds of polysaccharides as renewable feedstock for bioplastic synthesis may be evaluated for comparison. That's all from me. Thank you.